Mountains are amongst the most prominent physical features of our planet, and since time immemorial, human beings have held them in awe. For some, they were the abode of gods, revered and sacred, and for some, they were the realm of the unknown and even feared. The feelings of awe, grandeur, and even fear are natural, for mountains comprise some of the most awesome and spectacular landscapes on Earth. Extending for hundreds and sometimes even thousands of kilometers across the surface of the Earth, in continuous tracts, mountains in places may rise to many kilometers above the sea level. And because of their height, many of them are covered in snow. Often near the summit of these mountains are glaciers, rivers of ice, that erode the mountains and give them their fantastic forms. Many fast-flowing rivers and streams cut deep gorges and valleys in these mountains. Mountains are of different sizes and shapes. Any feature that rises 300 meters above its surroundings and has a wide base and a tapering top comes under this category. Sometimes distinction is made between a hill and a mountain on the basis of a height limit. In our country, for example, a mountain is differentiated from a hill when its summit rises to more than 900 meters above the base. But quite often, distinction between hills and mountains depends on local usage. A series of mountains is called a mountain range. Some of the important mountain ranges of the world are the Himalayan mountain range bordering the Indian subcontinent. This mountain range has 30 of the world's highest peaks. The Andes mountain range in South America is the longest mountain range on land, stretching over 6,000 kilometers. The other prominent mountain ranges of our planet are the Alps in southern Europe and finally the Rockies in North America. Mountains are found not only on every continent, but they also cover much of the sea floor. In fact, the longest chain of mountains is under the sea. This chain, the mid-ocean ridge, encircles the entire Earth. Its size is staggering. This mountain range is over 64,000 kilometers long. Whether underwater or on land, there are 4 distinct types of mountains found on our planet. The majority and the most common type of these mountains are fold mountains, formed as a result of folding of rock strata. Many of the highest peaks on the continents are fold mountains. Another kind of mountains are formed by the movements along a fault or a break in the Earth's crust. These are called block fault mountains. Volcanoes are yet another distinct kind of mountains. They are formed as a result of eruptions of molten rock from the interior of the Earth. The fourth kind of mountains are domes or batholiths. They are formed when molten rock rises within a continental plate. Let us see how these different kinds of mountains form. These bands of rocks are called sedimentary rocks. Millions of years ago, they were deposited in an ocean. We know this because they are layered and they contain fossils of marine organisms. But these rocks today lie 4,000 meters above the sea level. How did they rise 4 kilometers above the sea level? The contortions or folds in this rock strata clearly give us an idea of the tremendous compression and uplift that these rocks have been subjected to. Some rock strata have been lifted 90 degrees from the horizontal plane and are almost vertical. Where did this pressure emanate from? What caused it? These pressures were created from deep within the Earth's interior. This pictogram shows us the interior of the Earth, the crust, the mantle, and the inner and the outer core. The crust comprises of 2 different types of rocks, the lighter rocks of which the continents are made, and the denser oceanic rocks, which form the ocean floors. The oceanic crust is thinner, less than 6 kilometers. On the other hand, the continental crust is thicker, varying in thickness between 25 to 90 kilometers. The crust literally floats on the semi-molten interior of the Earth like a raft. The Earth's crust, however, is not in one piece, but broken up into large slabs called plates. There are 20 such plates on our planet. 7 of these plates are very large, and these are the North American, the South American, the Pacific, the Indo-Australian, the African, Eurasian, and the Antarctic plates. These plates are not static but move constantly. Their movement, however, is very slow, a few centimeters a year, much like the growth of a human nail. Let us see what causes these plates to move. The Earth's interior is extremely hot. Inside the mantle, scientists believe that the material is bubbling and churning and is driven to the surface by the enormous temperatures within the Earth's core, then cooling and sinking back. This circular flow of material is known as convection. It is these convection currents that make the crustal plates to move and collide with each other and to create stresses within the crust, which leads to the formation of mountains. Let us see how this happens. At the mid-oceanic ridges, the earth is splitting, allowing magma to rise through the asthenosphere. On either side, the crust or the lithospheric plates are moving apart. Where two plates converge, one, referred to as the slab, sinks. This process is known as plate subduction. In the process, the slab experiences massive increase in pressure and temperature until at a depth of 400 to 600 kilometers, where it melts and is absorbed in the mantle. This melting and friction release magma, which rises up through the overriding plate and creates volcanoes. In places on the earth where the continental plates collide against each other, the action can cause the earth's crust to wrinkle. These wrinkles that are pushed up in the earth's crust when the continents collide are called fold mountains. Many of the highest peaks on the continents are fold mountains. The Himalaya were formed as a result of the collision of two continental plates. The story of the Himalaya began when India separated from the supercontinent Gondwana land and started to move northwards, thereby closing the ocean that lay to its north. As India collided with Eurasia some 50 million years ago, it uplifted the ocean bed along with the continent to form the mighty Himalaya. The Indian subcontinent is still moving north against Asia, and these mountains are still active and being uplifted even now at a slow pace of a few centimeters each year. The effect of convergence of plates varies from place to place. The convergence of dissimilar plates may lead to the formation of volcanic arcs and mountain belts, like the Andes Mountains in South America. Here, the subduction of the oceanic plate led to the rise of magma to the surface, where volcanoes were formed. Volcanoes are cone-shaped mountains. A series of eruptions builds up lava, cinder, ash and rock fragments into a cone-shaped mountain. The top of a cone is a depression called a crater. These craters may be a few meters to even 2 to 3 kilometers in diameter. A crater frequently turns into a lake. Mountains may also be formed as a result of faulting or cracks in the Earth's crust. Block mountains are created through this mechanism. They give rise to level-top plateaus. Erosion, especially at the boundary of these plateaus, transforms them into spectacular landscapes like the Colorado Plateau in the USA. Tensional forces may also result in the subsidence of land as rocks on either side are pulled apart. Rift valleys are formed in this way. The Rift Valley in Africa has a length of 3,000 kilometers from Mozambique to the Red Sea. Batholiths and domes are yet another kind of mountains that are formed as a result of igneous activity within the Earth's crust. They are formed when molten rock rises within the continental plate. Instead of escaping through a volcano, it may grow and push up a bulge on the Earth's surface. The rock that covers this mass is called country rock, which when eroded away exposes the cooled and hardened mass, which is called a dome. Mountains are prominent physical features of our planet. On land, irrespective of their mode of formation or origin, they influence climate, vegetation, human activity, and also the economy of the geographical region in which they occur. On land, mountain ranges can affect weather patterns. Coastal mountain ranges cause moisture-laden air moving in from the ocean to rise. At higher altitudes, the air cools and the moisture it contains condenses to fall down as rain or snow. The slopes of mountains on the leeward side, the side away from the wind direction, are known as the rain shadow areas and are often very dry. The Tibetan Plateau is very dry as it lies on the leeward side of the Himalaya. A mountain may be so high that its climate varies from the base to its summit. For as the elevation increases, the air temperature decreases. Each of these temperature changes brings a marked change in the environment. In the Himalayan mountains, one can experience all the climatic types on the planet. From the tropical forests in the foothills to the evergreens till the timberline. Beyond the tree line, one encounters the alpine and the tundra conditions. The animals found in the alpine and the tundra zones are well adapted to the very cold temperatures as they all have shaggy coats of fur. As a survival strategy, the plants here are very small. The tallest may be only 1 meter high. They have small waxy leaves that hold water. Some of the plants are covered by hair-like fuzz that retains heat. Mountains are the storehouse of vast quantities of fresh water on which we are dependent. The natural resources like forests and forest produce are also another vital resource. Mountains also contain valuable mineral resources useful to us. Mountains are also the home of millions of people. For food production, these people terrace mountain slopes. This is to prevent soil erosion. Life in the mountains, however, is very hard. In the higher altitudes in the Trans-Himalaya, where there is little rainfall, People use water from snow melt for agriculture. There is a very short growing season, thus the people rely on limited varieties of crops like barley, peas and potatoes. Milk and meat comes from livestock. Mountains look indestructible, but the agents of weathering, wind, water and ice slowly reduce them. While erosion has been wearing away the mountains and hills, it has at the same time been filling up the valleys and the seas. In the 4.5 billion years of the Earth's existence, one would expect the Earth's surface to have been leveled out by now. But this is not so, for even as the Earth's surface is being worn and reduced, it is also being uplifted and rebuilt. These processes of Earth building, uplift, subsidence, folding and faulting, are constantly rejuvenating the Earth's surface and keeping the landscape alive.